variable, because activity depends on these values, on these descriptor values, but descriptor values depend on the structure only, nothing else. So they are independent variables, and the activity or toxicity will be dependent variable. And then we can use some kind of feature selection strategy to know of these descriptors are important for us. And once we know that, we'll use only those descriptors for model generation. These like multiple linear regression or partial squares, or maybe use analysis, or maybe logic regression, or we can use some machine learning algorithm classification, etc. And once we model, we have to check the quality of our model, because we have kind of data, and if the matrix obtained is not ill-defined, we will always get some kind of model, and we have to check whether it is statistically valid or not. So for that, we need to use different kind of statistical tests. And also, we have to use different kind of validation metrics to check whether the developed model is predictive enough or not on the new set of data. So we have different tools to understand that, whether the developed model is predictive on the new set of data or not. And once we are satisfied with the statistical quality and validation parameters, then we will use these for prediction purpose. And for a good model, if it is a regression-based model, if we have fitted values or predicted values, if we plot the calculated or predicted values against the observed ones, we will get scatter plot like this. In case of a good, so that degree of scatter will be low. Now, in case of the cost, how this similarity is measured, if we have only one determinant, in that case, the task becomes easier. We can use a graphical method like this, where we say we have the target compounds, we have a source compounds like this. So these are source compound, this is another source compound, and for that we can generate slope of this line using this expression, and then we can predict the target value of our compound that we want to predict using this expression. So here we are getting slope only from these two compounds, and then we are using both of the source compounds for prediction of the target value, that is Y0 of this compound. So here X1 is the feature for source compound, and Y1 is the expression or response of source compound 1, and X2 is the feature, and Y2 is the experimental value of the activity of the source compound 2. So we are using these two compounds, we are defining the slope, and we are getting the prediction for our query compound. Or we can use this, where you can see we are getting our slope from the two compounds, and then we are using only one compound for prediction, but we are using this slope. And here, our target compound is here, whereas our source compound is here. So this is a method of extrapolation, whereas in the first case, it is the interpolation, because it is in between the other two compounds. So in the latter case, we are using the compound which is closer to the target compound. So we are using this for prediction. The slope we are getting from other two compounds, but we are using this particular compound for prediction purpose. So this is a very simple example where we are using this graphical method for read-across prediction of the target compound. But in many cases, we do not have a single determinant. We may have several determinants. In that case, it becomes used simply method to get prediction, the query compound. That is what we do. We have to compress our data matrix. So we may have a data matrix or descriptor matrix that is large in size. So we have to compress this. using like principal component analysis. Principal component analysis is a data reduction tool which can compress the original dimensions of the matrix to a lower dimension. So it may so happen, say, initially we have 50 a number of descriptors, but after lowering dimensions, we may have 4 or 5 components only, and the first 2 components will be more important because they will explain the variance higher than the latter components. Now, if we plot this PC1 versus PC2, we can plot compounds, and compounds may be clustered based on the plotting, and based on that, we can choose similar compounds, because similar compounds will be in the same cluster. And based on that, we can choose compounds. Say, if our target compound is here, obviously we'll predict this compound using the source compound which reside in the close vicinity of this particular target compound. But if our target compound is here, then we will use compounds which are in this cluster. Or we can use a method like self-organizing map, which is a machine learning method similar to artificial neural network, but it is unsupervised. We do not use back propagation here, and here we use neighborhood kernel function. When the compounds will be projected here, the similar compound will be in the similar region of space. So we can select compounds which are similar or in the similar region of space to the target component. Based on that, we can get prediction. So in case of read across prediction, we will choose similar compounds to a target compounds for prediction purpose. I've already mentioned read across is something similar to quantitative structure activity relationship. But read across is not a statistical approach, whereas quantitative structure activity relationship is a purely statistical approach. So it is also important for us to understand the basic theories of QSR, because the same similarity principle applied is response activity of chemicals with descriptors representative of molecular structure and or property, and we use different kind of statistical tools for this. I've already described what are the descriptors. We have already described what is the dependent variable, that is biological activity or toxicity. So the basic notion of any QSR will be like this, where the biological activity is a function of the chemical descriptors. X1, X2, X3, these are the descriptors. And A1, A2, A3, these are the regression coefficient, these descriptors to the response. And these are signed values, this may be positive or negative. So from that, we can have idea about the positive or negative contribution of particular descriptors. Now, when we get this kind of relationship, actually this X1, X2, X3, these are descriptor values. So these are known from chemical structure or some derived properties. Method. So once these values A1, A2, A3, and so on, we have the equation known to us. We apply these to predict either tested compounds or new set of compounds. So we are able to predict the Y values of those compounds, and those compounds may be new compounds or untested compounds or unsynthesized compounds also, because from chemical structures we are able to derive the descriptors. So we can put the values in the equation, and we can calculate the Y values. And finally, this compound we can plot a scatter plot like this. So as I've already mentioned, from the QSR table, we apply different kind of feature selection technique. We apply different modeling algorithms to get the equation, and after appropriate validation, we can use it for prediction, and then we can use it for design of new compounds also. But it is important for us to know